Alright guys, today we're going to be taking notes over compound interest. So it's going to be very similar to the foldable that we were working on with simple interest last week. So if you've done so already, please print this out. If you don't have access to a printer, that is okay. Just follow along the best you can. Create your own if you want. Take your own notes. Do whatever you feel like you need to do. So first things first is we're going to cut it in half straight down the middle. Okay, once I've done that, I'm going to take my compound interest side, the one that says compound interest, I'm going to flip it over. Now, what I want to do here is I have all this excess space up here at the top that I really honestly don't need, and it's going to make it look a little funky. So what I'm going to do is I'm going to cut off this top piece right here, right above interest. Alright. Okay, once I've cut that off now, then the other thing I'm going to do is I'm going to cut off, actually I'm going to keep that, I'm going to cut off on the other one, okay, at the bottom of formula, alright, and on the other side it says example 1, so at the bottom of formula, I'm going to cut off that strip right there at the bottom as well. Okay, once I've done that, I'm going to flip it over. We're also going to cut off where it says solve for A at the bottom of that. Just cut off some of that extra dead space down there. Now the reason being I do that is so that when I do create this foldable at the end, it looks a little bit better than what it does. Alright, so what I want to do is I'm going to take this side first, the one that says compound interest on it. Okay, I'm going to flip it over. I want to look at the interest here. So what I'm going to do is I'm going to flip this over, okay, where it looks like so. And I have a little bit of white at the top here. Okay. So once I have that done, alright, so when I open it up, I should be able to see interest, example 6, and solve for I. Okay. Now I'm going to take my other one right here. Okay, I'm going to flip it over where I can see all the examples. Now with that, I want to take the formula and I want to fold it down to where it's right above the A. Like so. Okay, and that way I have plenty of space here. So once I've done that, I'm going to grab the other piece. Okay, right here above example 6 where I put my fold, I'm going to put a line of glue. I'm going to put a line of glue right there. Then I'm going to take my other foldable that I have in half, the one that says a formula on it. Okay, I'm going to have it folded. I want the A equals P. And I'm going to slide it in right into that crease right there. And then fold it over. And then make sure it's secure. Okay, once I've done that, now I should be able to see. Look, I see interest, I see formula. Oh, I see example 1, 2, and 3 on the solve for A. And then when I fold up this last part, okay, I'm going to put a crease right above example 6 right there like so. Okay, and then that way I can see example 4, 5, 6 and the solve for I. And then I'm done making my foldable. Okay, so now we can move on to the notes section. Alright, where we actually take notes over this. So compound interest is the interest on a loan or deposit calculated based on the initial principal and the accumulated interest. So basically what this formula already does for you, so before I move on, the interest on a loan or deposit calculated based on the initial principal and the accumulated interest. So essentially what this formula does for you is it already finds the total amount for you by taking the principal and the interest and already combining them together into one formula. Alright, now when you compound something, okay, rather than simple interest, where simple interest, what it does is every single year that goes by, the same amount of interest is added every single year. So if you so let's say you have, after 1 year on your loan, you have $200 of interest, and on the next year you have another $200 of interest, and the next year you have another $200 of interest. Okay, when something is compounded, the interest is actually increasing the longer you have it. So let's say you take out a loan, okay, and then the first year there's $100 of interest, and then after the second year there'll be $150, and in the third year there'll be $200, and in the fourth year $250, and so on and so forth, and the interest keeps increasing every year that goes by. Okay, so with simple interest it stays the same, the interest increases by the same amount every year, but with compound the interest increases by a different amount, by a larger amount every year. Alright, so simple interest is great to have when you're borrowing money, because it's going to be the same no matter what. But it's not really very good for when you're trying to save money. Compound interest is great to have for when you're saving money, but it's not a good thing to have when you're having to borrow or take a loan out on something. Alright? So the formula we're using is A equals P, and it didn't add it here, but we're going to add it, 1 plus R raised to the power of T. Okay, the A stands for the total amount. Now remember, we can find that by taking the principal plus the interest. That'll come in handy later. Okay, remember A is the total amount. So that's the total balance, the total amount on the loan, the total amount you owe back, things like that. P stands for principal. Okay, so again, principal is the amount borrowed or invested or deposited or something like that. R is the interest rate, and if y'all remember, it's a percentage and we have to convert it to a decimal. And then T is still going to stand for time, and it still has to be in years. So principal, rate, and time, they all mean the same thing. PR and T stand for the same thing, just they're in different places in the formula now. So for example, let's move on to example 1. We have Lily makes regular deposits to a savings account to save money for retirement. She deposits $1,000 into an account that earns interest compounded annually at a rate of 4%. How much will she have after 8 years? So again, this is what I was talking about. It's important to box in what type of interest it is. We know that this is going to be compound interest, meaning I need to use the formula A equals P times 1 plus R raised to the power of T. So then we're going to write out A, P, R, and T, and then go through and assign the numbers where they belong. So she deposits $1,000. Remember, if we deposit money, that's our initial investment, right? Our initial amount. So that's going to be your principal. It's at a rate of 4%. Okay, so that would go here. And then remember, we need to convert it to a decimal. So we move the decimal 2 times to the left, and it would be 0.04 for the rate. Then how much will she have after 8 years? 8 years being the time, it's already in years, leave it as is. So we have A, because A, we don't know what A is, it's what we're trying to solve for, is equal to P. Well, instead of P, we know P is going to be 1,000, so we're going to replace P with 1,000, parentheses, 1 plus, and instead of R, we're going to put 0.04, and instead of T, right, raised to the power of T, instead of T, we're going to put 8. So it's going to be raised to the power of 8. So that's exponents, guys. Remember, when exponents, what that number tells me is that tells me to multiply whatever's inside the parentheses by itself 8 times. So when we solve, we can use PEMDAS. Alright, So one way you could do it is you could take 1.1 plus 0.04. Alright, so we could write it out. Alright, we can do it as 1,000 times 1 plus 0.04 is 1.04 raised to the 8th power. So remember PEMDAS, so we do what's inside the parentheses first. Next is exponents. So we're going to take 1.04 raised to the 8th power. And I get 1.3685, so I'm going to do, let's do 4 decimal places. So it'd be 1,000 times 1.3686. So we're going to take that and multiply by it by 1,000. And I end up getting $1,368.57. Now, here's the other thing, guys. The great thing about having these calculators, or the great thing about the calculators I told y'all to download onto your phone, is we can literally just plug it in as it is. So if we do that, we type it in 1,000 parentheses 1 plus 0.04, and then we use this little up arrow right below clear. You can click that, and that raises it to a power. So you raise it to the power of 8. Then we press enter, and I get same answer. A equals $1,368.57. Remember to round it to 2 decimal places. So it's not 0.56, it's 0.57 because the 9 rounds the 6 up to a 7. And then that is your correct answer. Example number 2. Hay has $1,500 in a retirement account, earning 5% interest compounded annually. After 5 years, what was her account balance if she did not make any withdrawals? Okay, so we have $1,500 in a retirement account, earning 5% interest compounded annually. After 5 years, what was her account balance if she did not make any withdrawals? Okay, so we know it's going to be compound because it says compounded. So we know that we're going to use A equals PRT, or I'm sorry, A equals P times 1 plus R raised to the power of T. So we have A, P, R, and T. She has $1,500 in a retirement account, so that's our starting balance because that's how much is in the account to begin with. That's going to be our principal. We're earning 5% interest, so that means that it's going to be, that's our rate. Remember, rate is always going to be a percentage. We convert it to a decimal, so it'll be 0.05. And after 5 years, so that would be my time, T for years. Then we just plug everything in. So A equals 1,500, because that's where we put, instead of that, we put P, we put 1,500. And then we have parentheses 1 plus R. Well, R is 0.05. Raised to the power of T, which in this case is 5. So again, make your life easy. Download that app. Right? It's Graphing Calculator X84. We do 1,500, parentheses, 1 plus 0.05, raised to the power of 5. Get it out, and we get $1,914.42. So this should be pretty simple, guys. Similar to what we were doing last week. It's just a different formula. So as long as we recognize what everything is, we should be able to plug it into the formula and get the answer pretty easily. Example 3. Kim invested $5,000 in a 3-year certificate of deposit, or a CD, that pays 2.3% interest compounded annually. What will the CD be worth at the end of 3 years? So we know it's compound. It says compounded. So we're going to use A equals P times 1 plus R raised to the power of T. So we have A, P, R, and T. Kim invested $5,000, so that's going to be our principal because that's your initial investment. It's a 3-year certificate. right? Because what it's going to be worth at the end of 3 years. So that would be my time. And it pays 2.3% interest. That's my rate. But remember, we have to convert from a percentage to a decimal by moving the decimal 2 times to the left. So that would be 0.023. And we have to figure out A, the total amount that the CD will be worth. So we have A equals, instead of P, we're going to put 5,000, parentheses, 1 plus the rate, R, so that would be 0.023, raised to the power of T, which would be 3. Then again, use your calculator. Get out your calculator, get the app I told you to download, plug it in. So 5,000, parentheses, 1 plus 0.023, close the parentheses. Raise it to the power by using this little up arrow underneath clear, and then we're going to use 3 for 3 years. So it looks like that. Then round it to 2 decimal places. So that would be $5,352.99. Well, that 5 rounds that 9 up, and which rounds it up to a 5,353. Now in this case, I would have accepted 5,352.99. I think that's close enough, but this is the answer I would prefer to see. Alright, so do that. I'm going to post part 2 tomorrow for you to work on, going over the other half, but this is the notes that we're doing for today. Once you get that done, if you finish and there's still time in class, then you need to work on Dreambox. Alright, I'll see you all tomorrow.